Good day, everyone. So, today we shall be diving into questions and answers on alternating current, the part two of it. The part one talk about questions and answers on alternating current involving only resistors alone, capacitor alone, and inductor alone. But this time around, we shall be looking at questions and answers involving the combination of resistors and capacitors, combination of resistors and inductor. All right, without much ado, let's dive into this. Example 1, it says, a circuit consists of a 10.0 ohm resistor and a 0.8 Henry inductor connected in series to a 240 volt 60 hours AC source. So draw the circuit diagram of the arrangement and calculate 1, inductive reactance, 2, impedance of the circuit, and also lastly the capacitance of the capacitor that must be connected in series with this component to obtain maximum current, and take pi to be 3.142. Okay, so this question is very simple. And now, if you are we are going to write our parameters. Let's go to the question again. A circuit consists of a 10.0 ohm resistor, meaning that our resistance R is 10.0 ohm. And it also has an inductor of 0.8 Henry, meaning that our inductance is 0.8 Henry. And then the source of the power supply has a root mean square voltage of 240 volts. So we have root mean square voltage to be 240 volts and a frequency of 60 hertz. 60 hertz. And then we are meant to draw the circuit diagram of the arrangement. Now, this is a combination of resistor and inductor. This is the circuit diagram. They are connected in series. Series arrangement means that the component are side by side and their positive terminal is connected to the negative terminal of the other. Okay, so this is the series connection, and this is the alternating current supply with 240 volts and 60 hertz. This is the circuit diagram as being asked in the first question. Then we are made to calculate the inductive reactance, that is our SL. Our SL is used to represent our inductive reactance. We are also made to calculate the impedance, that's the Z. The Z is the impedance. And lastly, the capacitance of the capacitor, that is our C. So we are made to calculate three things: inductive reactance, impedance, and capacitance. Okay, so for the first one, which is inductive reactance, by formula, inductive reactance is the product of 2 pi frequency and inductance, that is 2 pi FL. Okay, so 2 is a number, it's a constant, so 2 multiplied by pi is also a constant, and here we are giving pi to be 3.142 in the question. So we substitute that 2 times 3.142 times f. Our f is the frequency, that's f equal to 60 hertz, to 60, then times L, our inductance. Our L is times 0.8. So when we simplify all of this with our calculator, we have our inductive reactance to be 301.63 ohms. Second part, say we should calculate the impedance of the circuit. The impedance of RL circuit. RL circuit simply means the circuit consisting of resistor and inductor. So the impedance of RL circuit is simply obtained with this formula. Z equals square root of resistance squared plus inductive reactance squared. And so we have our square root. Our resistance is already known to be 10, so it's square of 10 plus, we've calculated our inductive reactance in the first place to be 301.63, so square of that as well. Then when we simplify all of this and find the square root, we have our impedance to be 301.8 ohms. Okay, And thirdly, we are made to calculate the capacitance of the capacitor. So by formula, the capacitance of the capacitor is equal to 1 over 2 pi F, um, 1 over 2 pi Fsc. But in this case, because we have to obtain the capacitance of the capacitor when we have a maximum current. And this maximum current is obtained when capacitive reactance is equal to inductive reactance. So in this case now, capacitive reactance is not given, but since the current is the maximum, capacitive reactance is the same thing as inductive reactance, this SL. So we are going to be having our XL in the formula. So capacitance is equal to 1 all over 2 pi F SL. That is equal to 1 over our 2 is constant times our pi is 3.142. Our F is the frequency, that's 60 in the question, and our inductive reactance has been obtained to be 301.63. 301.63 is what should be here. So this is 301.63. All right, so that's our capacitive reactance, and the final result for the capacitance is 8.8 times 10 to the power minus 6 farad. So that's it. All right, we've been able to solve question 1 successfully. Let's take another question. Here it says, for the diagram shown below, calculate the inductive reactance of the circuit. And this is the diagram. This is still RL circuit because R represents resistor, L represents inductor. So it's the combination of inductor and resistor. This is the diagram for the question. And the second question says, if the current in the resistor R, this resistor here, is 0.05 ampere, calculate the potential difference across the inductor. So now let's start our parameters again. Firstly, in the diagram, our parameters is already stated. This 0.25 Henry here is our inductance. So our inductance is 0.25 H. That's our L. Remember, we have to calculate the inductive reactance. That's our SL. SL is unknown. Also, we are given the root mean square voltage to be 50 volts. So root mean square voltage here is 50 volts in the diagram. We are given frequency also to be 100 over pi. So frequency is 100 over pi hertz. And then lastly, we are told that if there is a current of 0.05 ampere flowing to the resistor, so we are given I is the current to be 0.05 ampere. We are meant to calculate the potential difference across the inductor. The potential difference across the inductor is known as the inductive potential difference. Okay, and that is our VL. VL represents the potential difference across the inductor. So, okay, so we are looking for two unknown. We're looking for the inductive reactance and we are looking for the potential difference across the inductor. So starting with the inductive reactance, by formula, inductive reactance is supposed to be 1. Inductive reactance is SL equals 2 pi FL, alright? 2 pi FL. So our 2 is still remaining constant 2 times. Pi is 3.142. But then we are not going to substitute the value of pi, reason being that our F, which is 100 over pi, is already having pi. So pi we cancel pi times our inductance, which is 0.25. Then when you simplify of this, pi cancel pi, 2 times 100 times 0.25, everything here will give us 50 ohms. So our inductive reactance is 50 ohms. Then the potential difference across the inductor, which is VL, is equal to I times inductive reactance. Our I is already given to be 0.05 times our inductive reactance, which we have obtained to be 50. So 0.05 times 50 will give us 2.5 volts. So the potential difference across the inductor is 2.5 volts. All right, let's go on with the next question, and that is example 3. All right, so here it says an AC source is connected in series to a capacitor of capacitive reactance of 10 to the power 3 root 3 ohms, and the resistor of resistance 10 to the power 3 ohms. The impedance of the circuit is what? So we are going to calculate the impedance. So let's write all the parameters given. So we are given the capacitive reactance to be 10 to the power 3 with 3 ohms. So our XC is our capacitive reactance is 10 to the power 3 with 3 ohms. We're also given a resistance of 10 to the power 3 ohms. So and we are to calculate the impedance. The impedance is concerned with Z. So Z is unknown. To obtain impedance in this circuit, Z will be equal to square root of square of resistance plus square of capacitive reactance. So resistance is already 10 to the power 3. So we substitute the value of R into this formula. So we have 10 to the power 3 or to the power 2. Then plus our capacitive reactance is given to be 10 to the power 3 root 3. So 10 to the power 3 root 3 all squared. Then when you simplify this, picking up the calculator, simplify all of this and look for the square root, we have our impedance to be 2000 ohms. 2000 ohms. Alright, let's go on to solve another example. It says here, in the AC circuit below, the current value is what? We have to obtain the value of the current flowing in this circuit. Alright, let's quickly write our parameters. This symbol is a symbol of resistor, so it has a resistance of 30 ohms. And this is a symbol of capacitor. It has a capacitive reactance of 40 ohms. So we have our current to be obtained. So I is unknown. R is 30 ohms as we have said earlier. And capacitive reactance is 40 ohms as we said before. Then we are told that the source of the power supply has 200 volt as its root mean square voltage. So we have 200 volt as root mean square voltage and frequency of 50 Hz. So to get the current flowing in the circle, current is equal to root mean square voltage over the square root of the sum of square of resistance and square of capacitive reactance. Okay, that will be equal to our root mean square voltage is 200, so we have 200 over the square root of resistance is 30, so 30 square plus capacitive reactance is 40, so 40 square. So simplifying all of these, the electric current flowing with our I will be 4.00 ampere. Alright, so let's go to the last question for the day. Example 5, it says the resistance in a series RC circuit is 5 ohms. If the impedance of the circuit is 13 ohms, calculate the reactance of the capacitor. In other words, we have to calculate the capacitive reactance. So right now, our parameters out, we are given resistance with 5 ohms. Our R is 5 ohms. We are given impedance, that's our Z, to be 13 ohms. 13 ohms, Z equals 30 ohms. And we have to find the capacitive reactance or the reactance of the capacitor. That is our XC is unknown. So XC by formula is square root of the square of impedance minus square of resistance. The square root of impedance is 13, so 13 square minus resistance is 5 square. Simplifying of this, the capacitive reactance will be 12 ohms. Alright, thank you for listening. Have a wonderful time. Bye for now.